Let's solve few problems on LPP now. Look at the first one. Maximize z is equal to 3x plus 4y. Remember, this is the objective function. What are the variables x and y, the decision variables? Then, what are the constraints given? See, there are three constraints what we have in this question. See, this is 1, 2 and 3. Correct? Now, we'll start with the maximizing part. All right. So, the first one, let's write down the first part, that is the objective function. Z is equal to 3x plus 4y. Very simple. Then look at the constraints. The first constraint what we have is x plus y less than or equal to 4. Right? X is greater than 0, y is greater than or equal to 0. I mean, both are greater than or equal to 0. Now, see, every constraint what we have has a particular, you can more like you can say it has a particular reason why it is given. Here, when you say less than or equal to, it's a bounded region. And x greater than or equal to 0, y greater than or equal to 0. Everything has a reason to it. Alright. First, let's try to figure out how do we plot it, because they're saying, solve it or show it graphically, right? Now, look at the first function. You have x plus y less than or equal to 4, right? What if you take x as 0? See, if you take x as 0, then y is equal to 4, correct? Or when y is equal to 0, then x is equal to 4. Make sense? Now, x is greater than or equal to 0, y is greater than or equal to 0. See, if x is equal to 0 is the line of y-axis, y is equal to 0 is for the x-axis. So, we also have to take these two. Okay, now let's do the graph part. Look at the graph. See, you have the x-axis and y-axis, correct? Now, guys, x is greater than 0 or x is equal to 0 and y is equal to 0. That's the x and y axis. That's okay, well and good. Now, we are going to look at the line, that is x plus y is equal to 4. See, when x is 0, y is 4. When y is 0, x is 4. Correct? Now, what are we going to do? We are going to join this as a line. So, when you take this, see, we'll make a line. So, where we have one point here, we are going to have one more point here. Now, join this one. Now, the region what we are going to take, that's very, very important. See, x plus y less than or equal to 4, correct? Less than or equal to 4 in the sense what? This area, isn't it? Less than 4. And the next point is what? X is greater than or equal to 0. Greater than, that means this area, greater than. And y greater than 0 is this area. So, what do we get here? So, if you take all of it together, this region is the region what is required, isn't it? See this region. Now we call this as the feasible region, if you remember. Right now, in the feasible region, now what we do, we take the corner points. So this is called as the corner point method. Now what are the corner points? Let's call this as A, let's call this as B. Now O, A, B are the three corner points, correct? Now what are the coordinates of A? So A value is 0, 4, B value is 4, 0, C value, or sorry, O value is 0, 0. Right? Now what we do, we take these three values and put it in the objective function. Alright? So for the maximizing part, what do we have? We'll take the function now. Alright? Z is equal to 3x plus 4y. Correct? Now when you take point A, then Z will be equal to 0 plus 16, which is 16. Right? If you take B, Z is equal to 12 plus 0, which is 0. And if you take O, answer is 0. Which is the maximum? Maximum is going to be this, which is nothing but point A, correct? A is going to be the maximum. So the optimal solution for this is 0, comma 4. Again, I'll tell you the optimal solution is 0, comma 4. And what is the maximum? What is the value of the maximum? Maximum value is 16. Clear? Maximum value and optimal solution. You get the maximum value by using the optimal solution. Clear with this? So this is how you solve the problems in LPP. So this is the answer for the first one. Now let's move to the second one. See the second problem? Again, maximize, subject to two conditions are there, correct? So second one. Now what we do, take the first condition, that is 3x plus y is equal to 15. Next is 5x plus 2y is equal to 10. Of course, it's greater than or equal to 0, y greater than or equal to 0, correct? Now 3x plus 5y is equal to 15. Start with the values. Now suppose if x is 0, then y is 3, correct? Suppose if y is 0, then x is equal to 5. The first point. Then second line, if you have to do it, suppose if x is 0, then y is 5, right? Then if y is 0, then x is equal to 2, correct? Let's draw the graph. See the first line, when x is 0, y is 3. So when x is 0, y is 3. When x is 5, y is 0, correct? So the first line what we have here is going to be, so in this case, we start from this point and we go all the way till here. And we go all the way till here. See, this is the first line, isn't it? Now, the second line. So for the second line, when x is 0, y is 5. When y is 0, x is 2. Right? So what we have now is this point goes here and this point goes here. Isn't it? So the line is going to look something like this. Make sense? Now, the other 2 points are what? X is greater than or equal to 0, y is greater than or equal to 0, correct? So the feasible region here, remember, look at the values. This is less than or equal to, less than or equal to, correct? So the feasible region is going to be this, right? So this is the feasible region. Now let's look at the corner points. See, this point we'll call it as A, B, C, and this point is O. So we have 4 corner points, isn't it? Now A and C, it's very easy to calculate. We already know it, right? See, point A is nothing but this point, correct? Point A is 0, comma 3. Point C is also very easy to calculate, which is 2, comma 0. And you know point O is 0, comma 0. Well and good. But point B is the intersection of both the lines, isn't it? So we need to solve and get the value of A and B. Sorry, A and B in the sense that X and Y value. So now what do? We solve it. Normal linear equation in two variables solving method. Alright. See, when you're normally solving, what you're going to have, you have the two equations, right? What are the two equations? You have 3x plus 5y is equal to 15 and 5x plus 2y is equal to 10, right? See, when you're solving, you can use elimination method if you want. It's quite easy also to use the elimination method. So you're going to have 15x plus, so this is 2, correct? 15x plus 25y is equal to 75 and 15x plus 6y is equal to 30. Subtract, 15 gets cancelled. 25 minus 6 is going to give us 19 is equal to 45, right? So y is equal to 45 divided by 19. Now what do? We are going to keep the same thing and we are going to put it back in the y to get the value of x, right? So you have 3x plus 15 into 45 by 19 is equal to 15. So 3x is 15 minus, see, 5 into 45. 45 into 5 is going to give you 225. 225 by 19. So 3x is equal to 15 into 19, 285 minus 225 by 19. So 3x is 30 by 19. So we have x is equal to 10 by 19. Right? So we got the next point, that is point B is nothing but 10 by 19, comma 45 by 19. Correct? Now what is the next point? We need to put this in the maximizing part, that is the objective function, to figure out which is going to give us the maximum value. Correct? Now let's substitute. See, my function z is equal to 5x plus 3y. Correct? Now put the values. Now we have the points. First is 0, comma 3. Next you have 2, comma 0, 0, comma 0, 10 by 19, comma 45 by 19. The first one is going to give us 0 plus 9, which is nothing but 9. Next, 10 plus 0, which is 10. Next, 0 plus 0, which is 0. Now, the last one is 5 into 10, 50 by 19, plus 45 into 3. 45 into 3 is 135. 135 by 19. So, which is nothing but 185 divided by 19. Right? See, no matter, even if 185 by 19, you don't have to divide it. Because 190 divided by 19 would be 10, right? But this is 185, which is lesser than 10. That means, what is our optimal solution? Optimal solution is this, maximize, right? So optimal solution is 2, comma 0, and the maximum value is 10, isn't it? So we can write the point or the solution is 2, comma 0, and the value is 10. This is the answer for the second question. See the third question? Again, minimize. That means minimum value. So minimize, that function is there anyway. Let's start with the constraints. X plus 3y is equal to 3 and x plus y is equal to 2, correct? So what do we have? X is 0, y is going to give us 1, right? And when y is 0, x is equal to 3. Well and good. Next one, when x is 0, y is 2. When y is 0, x is 2. Right? Very simple, very easy. Now, let's draw the graph. The first one, x is 0, y is 1. So, x is 0, y is 1. X is 3, y is 0. Correct? So, let's draw the graph. Basically, let's draw the line. So, this is 1 point and this is going to be one more point. So, here we have the first line. Here we have the first line. The second line, we have when x is 0, y is 2. X is 2, y is 0. So this is the next point, correct? So in this case, again, when you take it like this, so let's mark the point. This is 1. Okay, so this is 1 point. and this is going to be another point. Now the line, see, this is going to be the graph, correct? This is going to be the graph. Now we need to look at the area, isn't it? So this is going to be the area or the required feasible region, isn't it? Now we need to look at the point and need to do it. So what are the points here? So we have point A, point B, point C, and O, correct? So point A is nothing but 0, comma 1. Point B, we need to solve it. Point C is going to be 2, comma 0. Point O is 0, comma 0. Point B, we need to solve it now, isn't it? Linear equation. So what are the two equations? The first equation is x plus 3y is equal to 3. X plus y is equal to 2, right? Subtract directly. If you subtract 2y is equal to 1, y is equal to half. Substitute. X plus y is half. Sorry, x plus y is 2. So x plus half is equal to 2. So x is 3 by 2, right? So what do we have? We have 3 by 2, comma 1 by 2, right? Now let's do the optimal function. Now let's do the objective function, all right? So what do we have? Z is equal to 3x plus 5y. Remember, we are minimizing this, isn't it? So my first point, 0, comma 1. Next one, 3 by 2, comma 1 by 2. Then 2, comma 0, 0, comma 0. Correct? Now when we talk about 0, comma 1, this is nothing but 0 plus 5. 5. Remember, we are minimizing, not maximizing. Put 3 by 2. 9 by 2 plus 5 by 2. Correct? Which is 7. 14 by 2, 7. 2, comma 0 is 6 plus 0, which is 0. 0 plus 0 is 0. Or 6 plus 0 is 6. Now you might be thinking, yeah, my minimum point is 0, comma 0. Correct? But guys, remember, we are trying to minimize the function, right? When you are trying to minimize the function, 0, comma 0 cannot be a point. Even though it is a corner point, that cannot be the answer. So the answer is going to be this. Okay, so the optimal solution for this is 0, comma 1, and the value of this one is going to be 5. So this is the answer for the third one. Now let's do the fourth one. Look at the fourth one. See, in this one, we'll start with the constraints. X plus 2y is equal to 10. So take x as 0, y is equal to 5, right? Take y as 0, x is equal to 10, correct? The next one, 3x plus y is equal to 15. So take x as 0, y is 15. Take y as 0, x is equal to 5, correct? Now let's do the graph. The first line, see, when x is 0, y is 5. So when x is 0, y is 5. When y is 0, x is 10. So x is 10, correct? So first let's draw the line. So the first point and this is the second point. See, this is the first line, correct? Now for the second line, when x is 0, y is 15. When x is 0, y is 15. Then x is 5 and y is 0. So here again we need to draw the line. Yeah, so now this is the second line, correct? Now once we have both the lines, now the feasible region, guys, looking at this only you can figure it out, correct? So the feasible region, one, see, both of them are lesser. So this is going to be the feasible region, right? Now the points A, B, C, and O, correct? Now point A, C, and O, very simple. Now point A is nothing but 0, comma 5. Point C is nothing but 5, comma 0. Point O is 0, comma 0. Now what we need is point B. Use the same logic what we did. Do the linear equation. Yeah. So you have x plus 2y is equal to 10 and 3x plus y is equal to 15. Now multiply the second equation by 2. So you get 6x plus 2y is 30 and x plus 2y is equal to 10. Subtract 5x is equal to 20, x is equal to 4. Correct? Put it in the equation. 4 plus 2y is equal to 10. 2y is 6, y is 3. So my point is going to become 4, comma 3, isn't it? Now we have all the values. Let's put it in the function what we have. See the function. My function is z is equal to 3x plus 2y. Right? Now the points 0, comma 5, 5, comma 0, 0, comma 0, and 4, comma 3. Correct? Put the values. So first is going to be 0 plus 10, 10. Next is 15 plus 0, 15. Next one is 0 plus 0, obviously. The last one is 12 plus 6. 12 plus 6 is 20. Correct? So, what is the optimal solution? Optimal solution is 4, comma 3 and the maximum value is 20. Correct? So, the optimal solution is 4, comma 3 with a value is equal to 20. So, this is the answer for the fourth question. So here, I hope you guys have understood how to solve the LPP, correct? Remember, once you have the equation, you are going to have the constraints, correct? Along with the objective function, you are going to have the constraints. And once you have the constraints, then make the linear inequality into an equality. Draw the graph and then find the feasible region depending on the conditions given, greater than or lesser than, whatever. Then after that, you have the optimal solution based on the feasible region and also based on what the value the objective function is going to give you. Once you get the optimal solution, find the value, that's going to be the answer. Clear? So these are the problems what you can expect, and in the next video we'll look into the different type of problems.